In this part of the experiment, we want to determine the mass percent of acetic acid in vinegar. So acetic acid is the part of vinegar that makes it sour. All it is acetic acid in water. So vinegar is essentially watered down acetic acid. And it's usually 5% by mass, the kind that you buy in the grocery store. And we want to test this out experimentally. So at the end, we want to calculate the mass percent, and it should be very close to 5%. Here's the equation for the reaction. We're going to take acetic acid, the formula is given here, and this hydrogen is acidic. So again, it's going to react with the sodium hydroxide, and we produce a salt plus water. We know the molar mass of the acetic acid, and we also know the concentration of the sodium hydroxide solution. We're using the average concentration or molarity that we determined in part 1 of this experiment. Now for the data that we're looking at. The first thing we need to do is we need to weigh the amount of diluted acetic acid or diluted vinegar that we're using at the beginning of the experiment. So what we did was we took the vinegar that you buy in the grocery store and we watered it down a little bit more. So that will be the diluted vinegar in the fume hood. You're going to take your Erlenmeyer flask, zero it on the balance. You should have already measured out between 20 and 25 milliliters of the diluted vinegar in your graduated cylinder. It doesn't have to be exact. Pour that straight into the zeroed Erlenmeyer flask and record the mass of that. So that will give you the mass of just the diluted vinegar. The next thing you want to do is add Phenolphthalein Indicator and do your titration with sodium hydroxide like you normally do. You want to record the initial and the final burette readings. So after you do your titration, we can figure out how much of the sodium hydroxide we used. We'll take our final burette reading minus the initial to figure out how much we used. In this case, we have 49.30 milliliters as our final burette reading minus 19.55 milliliters as our initial. That gives us 29.75 milliliters of sodium hydroxide used. Since we're calculating a percent by mass of acetic acid, we need to figure out, based on our titration, how much mass of acetic acid, so how many grams, reacted with the sodium hydroxide. We can use stoichiometry and molar masses to figure that out. Here's the roadmap. We're starting with milliliters of sodium hydroxide that we used in our titration. Anytime we're using the concentration, we always have to convert to liters of sodium hydroxide. Then, using the concentration that we determined in part 1, we can go from liters to moles. From there, using our balanced chemical equation, we can go from moles of sodium hydroxide to moles of acetic acid. And finally, using the molar mass, we can go from moles of acetic acid to grams of acetic acid. Let's plug in all of our numbers now. So again, we're starting with milliliters of sodium hydroxide we used in the titration. So we're starting with 29. Let's make that a little bit better. 29.75 milliliters of sodium hydroxide. Next in our roadmap is we need to convert to liters. So we know that for every 1,000 milliliters of sodium hydroxide, we have 1 liter of sodium hydroxide. Next, we need to use our concentration that we determined in part 1. So we know that for every 1 liter of sodium hydroxide, we have 0.2137 moles of sodium hydroxide. Now we can use our balanced equation. If we look at our balanced equation again, we left out, we still have a 1-to-1 ratio. So for every 1 mole of acetic acid, we're going to react with 1 mole of sodium hydroxide. That makes our lives a little bit easier, but we still want to put it in our calculation. For every 1 mole of sodium hydroxide, we're reacting with 1 mole of acetic acid. The last thing is we need to get to grams. So we need the molar mass, which I gave to you with the equation. for every 1 mole of acetic acid, we have 65.05 grams of acetic acid. Okay. Once you calculate all that out, make sure that everything cross cancels. What you should get is 0.4136 grams of acetic acid. We started with 4 significant figures, which means we should end with 4 significant figures. The next thing we want to do is we want to take into account the fact that we took the vinegar from the grocery store and we watered it down. We have this conversion factor that tells us that 1 gram of the undiluted vinegar, so that's just the one from the grocery store, is equal to 4 grams of the diluted vinegar. Now we need to go back to the mass that we weighed out at the beginning of the experiment. So when we weighed out our diluted vinegar, we had 24.536 grams. So that's what we're going to start with in this case. So we have 24.536 grams, and this is of diluted vinegar. And we know from this conversion factor, for every 4 grams of diluted vinegar, we have 1 gram of undiluted vinegar. So essentially what we did was we just divided by 4. Once we do that, what we get is 6.1340 grams, and this is of undiluted vinegar. Again, this is just the vinegar that you get out of the grocery store. The last thing we want to do is figure out our percent composition by mass of acetic acid and vinegar. So that was the whole goal of this part of the experiment. To do that, we want to take the mass of acetic acid that we calculated that reacted with our sodium hydroxide, divide that by the mass of undiluted vinegar that we just determined, and again, since it's a percentage, we always have to multiply by 100%. Let's plug in our numbers. So from our calculation before, we figured out that the mass of acetic acid reacted is going to be 0.4136 grams. So that's what you calculated in part 5. Now we need to divide by the mass of the undiluted vinegar, which we just calculated. That's going to be 6.1340 grams times 100%. We should have 4 significant figures in this case, so our final answer is 6.743% acetic acid in vinegar. Now we want to think about if this makes sense. We said at the beginning that household vinegar is approximately 5% by mass acetic acid, so this is actually pretty close to 5%.